To IGNOU's classroom. You are here in Information Systems for Managers course. All right. So in this video, we'll be talking more about database resource management, which is the first unit in block 4, that is support systems for management decisions. So with another, I hope with another three more videos, we will be able to wind up this entire course on information systems for managers. So in this video or in this session, I am thinking of getting you acquainted with the importance of storing data, how we manage the stored data, how data is organized, what is DBMS, that is database management system, and its components, what data modeling is all about, what are the new developments in the database technology. You might have heard the term database admin. If any of your friends are working in IT field, definitely you might have heard this role or database admin. So what do they do exactly? A quick introduction to these kind of things, data warehousing and things like that. So let's get started. So what exactly are databases? Uh, we all know, and you might be aware by now, that we are generating a lot of data on a day-to-day basis, and the same way we are also consuming data, lots of data every day. You think about this video itself. I'm generating a lot of data, right? I'm talking to you, you are seeing this presentation, and you are consuming also. So whatever I'm saying, you're hearing, whatever is on the screen, you're reading. On top of that, you might be having your phone might be giving you the pop-up notifications. There might be other videos, ads might come up, a lot many distractions, or lots and lots of data that you are being bombarded with, and you're consuming every single day. So some of these actually we might need to store, and some of the data we can ignore. So the data we store is usually those data which we think or which we want to use later on. So a database actually lets us do this storage. Okay, it is a collection of data that is usually stored in the electronic form. That is what a database is. And it is typically designed so that it is very easy to store data in it, as well as access information or access data from it. So in order to build and use a database, a software management system called as the database management system is used, and that is used that will help us in developing all the related application softwares and all those things which will be used for managing our database. Basically what we are coming to say is that this DBMS, okay, it is a collection of software programs which allows people to develop application softwares for the creation, storage, modification, or manipulation of data from a database. So a database is simply a collection of data, like a warehouse. Think like that. Not a ware, like a storeroom. That is what a database is, like a storeroom. Okay. So, where exactly in the communication process do databases fit in? We all know that we are the end users, right? We use application softwares, okay? And the application softwares, we all know, links with the operating system, like Windows. It is the so all the application softwares are given, or the user interacts with these application softwares that are built on top of this operating system. So this application software, in order to work properly, you think like that. You create a Word document, you have to store somewhere, right? Either your hard disk or your floppy is long gone, sorry, USB device, or maybe in the cloud also, maybe on your OneDrive, wherever it is, you need to store somewhere. And then the next day, maybe if you want to do further editing, you will open that and do it, right? Similarly, the operating system also, somewhere it needs, right, a space to store these applications. Otherwise, when you open the computer again, if it is not stored somewhere, what will happen again? Every time you power off and power on your computer, you will have to start by installing softwares, right? That's not going to happen. So this database management system, or DBMS, actually lies in between your operating system and your application software. So how exactly is data organized in this DBMS? So think of this a big cylinder, okay, a big silo as your database, okay, and inside the database you'll have lots of files, okay, like think about your D drive or your documents drive. You will have a lot of folders which has a lot of files in it, right? Now inside a file, what all things would be there? Inside a file there will be lots of records or lots of lines. You can think of them as like that, okay. So just think about it, a collection of Word documents, okay, a folder having a lots of Word documents. So that folder will be like your database, okay. This is a very simplified basic explanation. Database is much larger than a folder, okay. It contains many folders, in fact, okay. But just for your understanding, I am saying it. Do not think that database each folder is a database. No, it is not like that. Okay, database is a big collection, a big, you can imagine a big silo or something like that. Okay, a big warehouse. So and then there are every and what you can say, files you can think of as each carton boxes in that big storeroom. Okay, and then so inside that carton there will be, let's say, lots of books. So books are like your records. Inside those books there will be units. So units are like your fields. Okay, so in each unit, there will be lots of subsections, right? That is like your byte. And in each subsection, there are lots of words or characters which make up that subsection. So that is like a bit. Okay. So bit is actually the simplest unit of information. Okay. That is bit. And bits are usually composed of zeros and ones. So zero is one bit and one is another bit. And as we had said in the earlier videos also, computers just understand two states. Okay. Zero, 1, on, off, that's it. Okay, so two states, two bits. Now with this on and off, various combinations of how frequently you're offing things and how frequently you're owning things and in what sequence, words get formed, special characters gets formed, operations get done, all those things happen like that. Okay, so that is what is the basic concept behind any computing device. It's the same with the database also. So 0 or 1 is a bit. Like that, if you join 8 bits you will get 1 byte. Like for example this one, many bytes come together, okay, to create, you might be knowing, megabyte, gigabyte, terabyte, kilobyte, all those petabyte, you know all those things, right? So basically they all say that these are the bits coming together, and depending upon the number of bits that come together to form the what you can say, the file or the record or the field, the size of that is determined. So now come to think of it like this. If you're taking just one word document also, or just one form, okay, there will be a lot of fields in it, right? So each record will have a lot of fields. Like that, a file will contain many records, and many records are clubbed into a single file. So like that, there will be a lot of files in the database. So that is how data gets organized, or data is organized in a database. I hope you got the generic idea about it. If you're still having doubts, let me know in the comment section. I'll be more than glad to help you out as much as I can. So what are the components of a database management system? We said that it is a collection of software applications. So what are those software applications that go into making of this database management system? So we have data dictionaries, disk managers, which disk managers are tasked with actually managing the various disks. So one database management system or one database may have multiple disks or multiple disk partitions. So how data gets stored in which partition and things like that are handled by this disk managers. Okay, then we have data manager or database manager. We have the data definition language compiler. Okay, that is DDL compiler. We may have query processors. Like usually, if you think about database management softwares or systems, and you search for them, what all you will find is the MySQL or PostgreSQL or things like that, Oracle, things like that you will find. Okay, so all of those things come. So the data in all of these gets queried or created or manipulated, all those things using um, something called a structured query language. Okay, SQL. There is also a NoSQL, that is non-structured query language. But whatever it is, there is a query language that is there. So to process that query and to convert that query into its own sequences of zeros and ones, so that the computer can actually process that query, we have a query processor. We have file managers, we have pre-compilers, as well as data dictionary, which has the collection of all the, what you can say, it's like a glossary where what is stored, like it's kind of like a help document, you can think of in the basic sense. Okay, so those are the various components of your database management system. Now coming to data modeling, data models actually refer to the different views of data, that the underlying relation and the underlying relationships among them. So actually, you can think of data modeling as that process of creating a model for the information system. It kind of like a visual representation of the information system, either the whole of it or a part of it. Now, in case you find that I'm talking faster than what you can catch up, there is a button in all our YouTube settings, okay, in the video itself, where you can adjust the playback speed. Feel free to increase or decrease it according to your comfortability. So coming back to our data modeling. So what data modeling or this data model gives us, it's kind of like a plan or a map. Think of it like that. It gives us the connections between the various data points. It illustrates the type of data that is used and stored within the system, as well as the relationships among these data types, and the ways the data can be grouped and organized, and all its formats, attributes, all those things will be given. This process is actually used to define as well as analyze the data requirements which are needed to support our business processes within the scope of corresponding information systems in our organizations. So why do we actually go for data modeling is because with data modeling we can reduce the errors in software as well as database development, increase the consistency of our documentation, improve the application as well as database performance. Ease of data mapping throughout the organization will be made possible. We can It can help to improve the communication between the developers as well as the business intelligence teams. It can help speed up the process of database design at the conceptual, logical, as well as physical levels. And it can help to manage data as a resource and be used to integrate information systems, as well as used in design of the data warehouse or data repositories and things like that. So these are only quite a few reasons why we should go for data modeling. It's not an exhaustive list by any chance. So coming to the data modeling process, first we create the conceptual model. So what the conceptual model does is it provides a view of what the system will contain and how it will be organized and which business rules will be involved. And then we have the logical model, which will provide a greater detail about the concepts and relationships in the domain under consideration. We have physical models which provide a schema for how the data will be physically stored within the database. And we have various types of data models also, like we have the object oriented model, the record based model, as well as dimensional models. So we will see about a few of these. For record based models, we could have it as in a hierarchical way, in a networked way, or in a relational way. Okay, so coming to the relational way, we have to understand about the entity relationship or ER models. So what happens here is in each entity and will have a so each entity and its relation will have a corresponding table, and each column will contain the data with respect to the particular attribute. You might feel these concepts a little bit confusing. Actually it is not, but if you are new to this whole concept of information systems and you do not have a prior computer science background, it will take some time and some reading to get it familiarized. But once you are done with it, once you're introduced into it, it will be very 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 easy for you. So in case you're finding difficult any concept, you're finding it difficult, feel free to google, and if you still are finding it difficult, leave a comment in the comment section below. I'll try my best to clarify your questions. So we talked about this entity relationship model. So what is this entity? You can think of it as any real world object: your cycle, your car, a pen, your bed, your AC, your fan, your clothes. Any real world object can be an entity. Now, attribute is a property of your entity. Like you take an example of your car. Okay, so car is the entity. Color is an attribute of the car. Model is an attribute of that car. Number of seats, number of airbags, engine capacity, petrol or diesel, or maybe even EV, right? Those are all attributes. And what is relationship? Relationship is the meaningful relationship between entities, and this degree of relationship could be either one to one, or one to many, or even many to many. We'll see about these things. Now, normalization is another term which you'll often come across when we talk about databases. So normalization, you must understand, is a process of converting very complex data into simple information or simpler forms without actually having any loss of information. So an easiest example which I actually can think of is like mm, some what you can say, take for example your photo. Okay, if you take your photo with a DSLR camera, that file is going to be quite bulky, but you have a lot of softwares available which can resize your photo, right? And when you resize the photo or compress the photo to a certain degree, you will get a reduced file size but with the same almost comparable quality, right? So it's like both the photos have the same information, but and visually also it is same, but internally it is a bit different. Similarly, what happens is that like some special characters and all, in Unicode it might be represented in one way, in say ASCII it might be represented in another way, okay, internally. But when the person sees it, when the user sees it, it will be the same. Okay, maybe that it might be the trademark symbol, just for example. Okay, um, internally it might be stored in different sequences of these zeros and ones. So what happens is that when you compare them, right, because of this encoding difference, you will find that they don't match. Okay, your codes will return a no match, for example. But when you look at it, you both cases you are seeing that it is the trademark symbol. Okay, take an example. So uh, what we do is we apply this process of normalization. It's not actually very complex. It's just, if you're using a query language, it's just one word called normalize and everything gets done. Okay, so it's not that we have to dig deep and write algorithms to get it done. At least from the high end programmer perspective, you don't have to do it. You just need to use that syntax or that command called normalize, and it will do it for you. What happens is that both these things will get converted to a simpler format and then compared. At that time, what will happen is that you'll hit a match. So that is the whole concept of normalization. I hope you understood it. These things are not, you just need to have a basic high level understanding of these concepts. Okay, because nobody's going to go and put you in front of a computer and ask you to code or ask you to do all these. But as a manager, you need to understand these concepts so that you can connect with your employees and the people you manage much better. So, what are the few developments that we are finding these days in database technology? We have the object oriented databases. Now we have the object relational databases. We have spatial databases, time series as well as temporal databases. We have text and multimedia databases. Earlier, it was not possible to store images and all, in the earlier days. But these days we can store images and things like that also. Heterogeneous databases are there. And the biggest of them all is the World Wide Web, WWW database. So, what exactly do these database administrators do in an organization? So, any large and complex database, if you're using it in your organization, then definitely you will need the help of a database administrator for its proper maintenance and schedule and things like that. So, this DBA actually controls the database and administers the overall user community of that database, like who gets to access what, who gets to read, who gets to write, how many files can you write, can you delete or no, can she delete or no, things like that. The overall control part of it, who gets to do what, that is being controlled by DBAs. So they are also responsible for accessing the database and making sure that unauthorized persons do not access the database. So the accessibility part also they have to take care. Storing and revoking permissions for users, they have to take care. Maintaining the integrity of data is also their responsibility. Okay, recovering database from failures, and you can think of actually DBAs as super users who are responsible for all the monitoring and improvement and performance and operations and things like that, so as to maintain all the database activities you know prim and perfect, so that everybody else who's using that database do not feel any issues with it. Their operations can run smooth. So DBA actually has quite a lot of responsibilities in his plate or her plate. Coming to what database and data warehousing is. So, Bill Inman's words, the warehouse is a subject oriented, integrated, time variant, and non volatile collection of data in support of management's decision making process. So, a data warehouse is actually a type of a data management system which is designed to enable and support business intelligence activities, especially analytics. It is a central repository for information and can be analyzed to make more informed decisions. Data flows into a data warehouse from the transactional systems, relational databases, and other sources, typically on regular intervals. So coming to what we read already, that is DBMS, then there is something called as Relational Database Management Systems or RDMS, and what we learned right now, data warehouse. Are they same? Are they different? If so, then how? All those things we'll try to understand. So this DBMS actually consists of a collection of interrelated data that is called as a database, as well as a collection of programs that will help in managing as well as accessing the data stored in the DBMS. An RDMS, on the other hand, is actually a collection of tables, each of which is assigned a unique name. And each table consists of a set of fields which stores large sets of records. And a data warehouse, on the other hand, is a repository of data that has been collected from multiple sources, stored under a unified schema, and it all resides at a single site. So I hope you understood the basic concepts of database resource management. In the next upcoming videos, we'll be talking about data warehousing, data mining, artificial intelligence, decision support systems, and ICT, and things like that. So I hope to catch you there. Thank you so much for being with me till the end. See you next time. Bye bye.